Chapter 5.3, Inverse Functions. Day 2, finding the derivative of inverse functions. Now if you remember, an inverse function means opposite. It's the opposite of a function. You take your x's, they become y's, and your y's, they become x's. In a table, they just switch values. What happens in a graph is you'll take your values, and it'll actually end up reflecting over the line y equals x. So an inverse function graphically kind of looks like that, where they're reflected over this line. A couple things you'll notice, that if the function is continuous, so is its inverse. All right? If the function is continuous, so it's the inverse. If the function's increasing, because you're just switching the x values with the y values, the inverse will still be increasing. Same thing with decreasing. Also, if you can take the derivative, you can take the derivative of the inverse, provided the derivative isn't 0. All right? And in fact, a little bit further, the derivative of the function is equal to the reciprocal of the derivative of the inverse at the point that's opposite. All right, so let's look at this and let's apply this. All right? So evaluate the derivative of an inverse. All right, we'll start. We have the question, f of x, what is the value of the inverse when x equals 3? So what is f inverse of 3 equal to? All right? Well, to answer that, if 3 is x in the inverse, what is 3 in the function? Well, that's like saying, where is f of x equals 3? X in the inverse is y in the function, and vice versa. X in the function is y in the inverse. So what is the value of f inverse of x when x equals 3? That's the same thing as saying, what is the value of y, or what is the value of x when y equals 3 in the function? So we'll set the function equal to 3. 3 equals 1/4 x cubed plus x minus 1. And for starters, these are going to be easy ones where you can kind of guess, all right? Kind of guess, do some trial and error, use brute force if you may. Not the best way to do it. I don't typically say use brute force. In this case, it's okay. Plug in 1, you can see we got 1/4 plus 1 minus 1. That's going to be 1/4. That doesn't work. Plug in 0, we get -1. Right? We're getting further away from 3. Since it's monotonic, it has an inverse, we can get closer to 3. Let's try 2. 2 cubed is 8. 1/4 of 8 is 2. 2 plus 2 is 4 minus 1. When x is 2, y is 3. So when our function is 2, the value is 3. Vice versa, when our inverse is evaluated at 3, the y value is 2. So what is the value of f inverse when x is 3? Well, 2, because when the function is 3, x is 2. All right? So let's answer the second part. What is the value of f inverse of x, f inverse prime of x when x equals 3? All right? Well, first we need to find f inverse prime. We can't really find f inverse. However, we can find f inverse prime. How can you do that? Well, follow the directions for finding an inverse first. We'll switch. So instead of saying y equals, we'll say x equals 1/4 y cubed, 1/4 y cubed plus y minus 1. Now our next step would usually be solve for y. We can't do it, so let's skip that step. And if you can't solve for y, remember you can still find the derivative implicitly. So what we want to do is do it implicitly. All right? So just take the derivative here. Derivative of x is 1. Derivative of 1/4 y cubed, use the power rule, would be 3/4 y squared y prime plus y prime. And then the 1 is a constant, so its derivative is 0. All right, now we plug in what we know. We are looking for y prime when x is 3. We don't have any x's, but we need a y right here. And we can see when x is 3, y is 2. So I'm going to plug in 2 there. So we got 1 equals 3 times 2 squared is 4. 3/4 of 4 is 3y prime plus y prime. Solve for y prime. We got 4y prime equals 1. So y prime is 1/4. Right? So we were able to find the derivative without finding the actual function. Also, I'd like to point out, if we go back, the derivative equals 1 over the derivative of the inverse. All right? What would be the derivative here of f? All right, the derivative of f would be f prime of x equals 3/4 x squared plus 1. And x is 3, so that would be, x is 2. X is 2. So that would be 3/4 times 2 squared is 4/4. 3 plus 4 is 4. So f prime of 2 equals 4. Notice the function and its inverse, the derivatives are reciprocals. Right? There's 2 ways you can look at these problems. You can look at it as find the inverse first, then you can plug in the point and find the slope, or you can find the slope and flip it to find the inverse of the slope. The inverse is slope. All right? I prefer the method I showed here first. I'm going to continue doing that method today. Tomorrow's video will be the second method. So let's just do a few more problems with the first method, or I think I got 2 more problems. All right, verify that f has an inverse, then use the function and the given value to find the f inverse prime at a. So we verify it first by showing that it's monotonic. F prime of x is 3x squared. There's a critical number at 0, but on the left side of 0 it's positive, and the right side of the 0 it's positive, so f is always increasing. F of x is increasing on all real numbers. All right, now I need to find out f inverse prime of a. Well, I know a is 6, so I'm looking for f inverse prime of 26. That's my x and my inverse, so it's my y in my function. So 26 equals x cubed minus 1. Go ahead, solve that. This one's not tough. Add 1, cube root. X equals 3, so f of 3 equals 26. That means f inverse of 26 equals 3. And now let's find the inverse. All right? My function is f of x equals x cubed minus 1. My inverse would be x equals y cubed minus 1. Take my derivative. 1 equals 3y squared y prime. Substitute in my y value. Remember, this is for the inverse, so I go to my y value for my inverse. 1 equals 3 times 3 squared is 27y prime. So the slope of the inverse is 1/27, or the slope at 26. All right. Verify that this has an inverse function, it should say. Then use the function to find f inverse prime of a. So first, verify. Take our derivative. We'll use the product rule because it's 1/27 times something. Product rule. First, derivative of the second. 1 over 27 times 5x to the 4th plus 2x squared, 6x squared. plus second derivative of the first. 1 over 27 is a constant, so that's derivatives will be 0. Find your critical numbers where it's equal to 0. That's never equal to 0. We'll factor this. 0 equals x squared times 5x squared plus 6. This will never be 0 because you can't square something and add a number to it and get 0. This is 0 at 0. Check left of it. Since this is squared, that's squared plus a number. That'll always be positive. That'll always be positive. So this is always increasing. So F inverse exists. Because the derivative is always positive. All right? Now we know a equals 11. That's x in the inverse. We need to find what that is in the function. So negative 11 equals 1 over 27 times x to the 5th plus 2x cubed. Go ahead, try some numbers. Let's try 2. 2 to the 5th is 32. 2 to the 3rd. We may have to do some more plugging and chugging on this one. Let's see here. We'll try 2 into x. Negative 11 over 1 over 27 times x to the 5th plus 2x cubed. Not big enough. Let's try maybe negative 1 into x and see what happens. All right, getting closer. Let's try negative 2 into x. Negative 3. Again, I normally don't advocate trial and error, but in this problem, we'll get you there decently enough. So when x is negative 3, the function is negative 11. So when the inverse function is negative 11, when x is negative 11, the inverse function is negative 3. Right? And then it's a matter of finding our inverse. We'll switch. So we got x equals 1 over 27, y to the 5th, plus 2y cubed. All right, take our derivative. We got 1 equals 1 over 27, 5y to the 4th y prime, plus 6y squared y prime. Plug in negative 3. 1 equals 1 over 27, 5 times 81 y prime plus 6 times 9 y prime. Then divide that out. Y prime equals 27 over 5 times 81 plus 6 times 9. I'm not going to calculate that all the way out for the interest of time, but you can see it works out to a nice, or a fractional number. All right, so in review, how do you know a function has an inverse function? It's monotonic. Take the derivative, and you see it's always positive or always negative. How do you find the derivative of a function? A function's inverse without finding inverse? Well, follow the inverse rules. Switch x and y, but instead of solving for y, derive it implicitly.